Dear students, let us continue our study in this paper, which is Forensic Chemistry and Explosives, and in this particular module we shall deal with explosives, that is, know what are explosives, how they are manufactured and the composition of some common explosive, and all this information is very important for you to know, because when at crime scenes where explosions have happened, you are there to investigate, then which type of explosive has been used and how to analyze, that becomes very important, and in order to do that you should have the knowledge of all this. We shall know about what are explosives, we shall be able to know what is explosion and the different types of explosion, and then what are the various types of explosives and the different types of improvised explosive devices also we will try to know, and some explosives will deal in detail for the manufacture and composition. If we talk about what an explosive means, an explosive is a substance, an element or a compound or a mixture which is capable of exerting pressure on its surroundings on explosion or transformation. Forensic science plays very important role in relation to explosives. Explosives studied by forensic personnel mainly relate to mass destruction episodes wherein bombs are used for illicit activities, and unfortunately these incidents are increasing day by day. The explosive residues collected from the crime scene are examined for such causes, especially the constitution of the explosive material, the source and intention of explosion. If we try to see what are the applications of explosive, an explosive have many applications which are legal and do not cause harm to any human, animal or any other living being. Actually, scientists have made explosives for the noble cause, and here I will like to add that dynamite was first made in chemical lab, and that was done by Alfred Nobel, and he made this for the noble cause, that is, in constructing roads when you are having big mountains as obstruction, then dynamite was initially used for creating way through the explosion where otherwise methods were not so successful. So, the scientist or the chemist who have made these, they have made for the noble cause, but it is the human instinct, the negative instinct which they have utilized for the negative, that is destructing other human beings or animals and so on. So, we have to understand that what is legal and what is not legal. So, there are legitimate applications of explosives and there are illegitimate application of explosives. When we talk about the legitimate uses, an explosive might be used in blasting rocks for mining, oil explorations, in satellite and spacecraft propulsions, in constructing roads, railway line, in firework display, and may also be used for military purposes, which we will discuss later. But when we talk about the illegitimate uses, the criminals are using the explosives for causing destruction to individuals or a nation on a whole by blasting bombs of various types. The illegitimate use of explosive cause large scale destruction as well as a threat to the integrity of any nation and is severely punishable under the Indian Penal Code, Explosive Act and the Explosive Substance Act. So, these two acts you should keep in mind. And when we talk about some common examples which are used. They are RDX, TNT, TETN, ANFO, dynamite, etc. Ripple Rock was an underwater twin-peaked mountain hazardous to ships passing through the Seymour Narrows of the Discovery Passage in British Columbia, Canada, and this was destroyed with the help of 1270 metric tons of Nitrobex 2H explosive. So, this you find is a positive use of explosive. Now, forensic science, if we talk about, forensics plays an important role in the investigation of explosion, where explosive substances or materials are the main ingredients. Explosives can be detected prior to explosions, that is during trafficking, and also after the explosion has taken place, and that is done by forensic spot test and also by various high tech forensic analytical tools. So, with this background, let us study all this in more detail with the help of graphics and visuals.
Types of explosion. An explosion may be exotic or chemical. The common examples of exotic explosion is nuclear explosion and the use of high intensity laser arc to heat a substance to its plasma state. Laser and electric energy are presently used only to start reactions rather than producing energy. Due to the existence of organic compounds containing NO2, ONO2, and NHNO2 groups and others, an explosion is an impulsive chemical reaction which is driven by enormous release of heat and energy. This type of eruption is known as chemical explosion. The chemical explosion is of three types: decomposition, deflagration, and detonation. The chemical decomposition of an explosive occurs during its storage. This can happen over years or days or hours or maybe within a fraction of a second. Deflagration and detonation are the two spontaneous types of chemical decomposition. Deflagration of the explosive substance is proliferated by a blaze front which travels gradually through the explosive substance. Low explosive experiences the process of deflagration. In detonation, the explosion is propagated by shock waves navigating through the explosive material. Detonation happens in high explosives. Classification of explosives. Explosives can be classified on the basis of composition, velocity, sensitivity, and physical forms. But broadly, explosives are of three types: low explosives, high explosives, and miscellaneous. Low explosives. Low explosives are solid flammable materials that deflagrate. Low explosives liberate enormous quantity of gases that generate sufficient pressure to force a projectile in a specific direction upon ignition and decomposition. The proportion of burning of explosive depends on combustion gas pressure, grain size and form, and composition. Low explosives experience deflagration at amounts that fluctuate from a few centimeters per second to about 400 meters per second. Gunpowder or black powder, smokeless powder, flash powder, pyrotechnics are few common examples of low explosives. Gunpowder. Gunpowder was the first chemical explosive. Gunpowder is an admixture of sulfur, charcoal, and potassium nitrate. The sulfur and charcoal acts as fuel while the potassium nitrate works as an oxidizer. Gunpowder has been extensively used as a propellant in firearms and as a pyrotechnic composition in fireworks, owing to the extent of heat and gas volume that it produces. Pyrotechnics. Pyrotechnics is a methodical technique involving the use of constituents skilled of undertaking self-contained and self-sustained exothermic chemical reactions for the generation of heat, light, gas, smoke, and or sound. Pyrotechnics has the propensity to change a fire into either a burst of striking fireworks or a dense cloud of clogging smoke. The fireworks are a blinking, fiery, short-lived burst of glowing, colored aerial lights. High explosives. The explosives that detonate, meaning that the explosive shock front passes through the material at a supersonic speed. These are commonly used in carrying out the activities involving mining, destruction, and military applications. The high explosives may be further grouped into primary and secondary high explosives. High explosives experience detonation with explosive velocity ranging from 3 to 9 km per second. RDX, PETN, TNT, ANFO are the examples of high explosives. Primary high explosives, the explosives which are extremely sensitive to mechanical shock, friction, and heat, to which they will respond by burning rapidly or detonating, are known as primary high explosives. Lead azide, lead stiffenate, DDNP, and tetrazine are some of the examples of primary high explosives. Mercury fulminate. Mercury fulminate is prepared by dissolving mercury in nitric acid and then pouring into ethanol. A vigorous reaction takes place which is accompanied by the evolution of white fumes, followed by brownish red fumes, and finally again by white fumes. At the same time, crystals of mercury fulminate are formed. The grayish colored crystals are recovered and washed with water until all of the acid is removed. Lead azide. Lead azide is a form of primary explosive. It is prepared by dissolving lead nitrate in a solution containing dextrin with the pH adjusted to 5 by adding 1 or 2 drops of sodium hydroxide. This solution is heated to 60 to 65 degrees Celsius and stirred. Sodium azide dissolved in a solution of sodium hydroxide is then added dropwise to the lead nitrate solution. The mixture is then left to cool to room temperature with continuous stirring. Lead azide crystals are filtered, washed with water, and dried. Secondary explosives. Secondary high explosives are also known as base explosives. They are comparatively unresponsive to shock, resistance, and heat. They may ignite when exposed to heat or flame in trivial liberated quantities. These are sometimes added in small amounts to blasting caps to boost their power. The secondary high explosives may further be divided into boosters and main charge. Secondary high explosive boosters. An explosive booster acts as a bridge between a low energy explosive and a low sensitivity explosive such as TNT. It increases the explosive shock wave from an initiating explosive to the degree sufficient to detonate the secondary charge. PETN and RDX are categorized as boosters. PETN, Pentaerythritol tetranitrate. PETN is prepared by nitrating pentaerythritol, which in turn is made by mixing formaldehyde with calcium hydroxide in an aqueous solution held at 65 to 70 degrees Celsius. Nitration of pentaerythritol is achieved by adding it to concentrated nitric acid at 25 to 30 degrees Celsius to form PETN. The crude PETN is then removed by filtration, washed with water, and then neutralized with sodium carbonate solution and finally recrystallized from acetone. This results in 95% yield of PETN. RDX Cyclotrimethylenetrinitramine 135 trinitropyrhydro 135 triazine. RDX is synthesized by adding hexamethylene tetramine to excess concentrated nitric acid at 25 degrees Celsius and warming it to 55 degrees Celsius. RDX is precipitated with cooled water and the mixture is then boiled to remove any soluble impurities. Finally, purification of RDX is carried out by recrystallization from acetone. RDX preparation processes. RDX is also formed by various other preparation techniques such as SH process, which was invented by Schnur, K process patented by Knopfler, W process patented by Wolfram, E process patented by Erbele, Ka method, also known as Bachmann process, which was invented by Knopfler and Apel. SH process involves continuous nitration of hexamethylene tetramine by concentrated nitric acid with the production of nitrous gas. The RDX is filtered from the residual acid and stabilized by boiling in water under pressure and purified by recrystallization from acetone. In the K process, RDX is formed by reacting ammonium nitrate with a mixture of hexamethylene tetramine and nitric acid and warmed. The W process is based on the condensation of potassium amidosulfonate with formaldehyde and the nitration of the condensation product. Potassium amidosulfonate and formaldehyde are reacted together to produce potassium methylene amidosulfonate. This product is nitrated to RDX by a mixture of nitric and sulfuric acids. In the E process, paraformaldehyde and ammonium nitrate undergo dehydration by acetic anhydride solution, resulting in the formation of RDX. Ka process is based on the reaction between hexamethylene tetramine dinitrate and ammonium nitrate with a small amount of nitric acid in an acetic anhydride solution. HMX Cyclotetramethylene tetranitramine. HMX is formed as a byproduct during the manufacture of RDX by the Bachmann process. Hexamethylene tetramine, acetic acid, acetic anhydride, ammonium nitrate, and nitric acid are mixed together and heated at 45 degrees Celsius for 10 minutes. Ammonium nitrate, nitric acid, and acetic anhydride are then slowly added and left on a steam bath for 12 hours. A precipitate form which contains 27% RDX and 73% HMX. HNS hexanitrostilbene 1112 ethenediol bis 246 trinitrobenzene. HNS stands for hexanitrostilbene and can be prepared by many methods. For example, by the reaction of nitroderivative of toluene with benzaldehyde, by the reaction of nitroderivatives of benzyl halogenide with alkaline agents, by removing hydrogen halogenide, and also by the oxidation of nitroderivatives of toluene. 1. The first reaction involves heating a mixture of trinitrotoluene with trinitrobenzaldehyde at 160 to 170 degrees Celsius and then cooling the mixture for 2 hours. The product is a low yield of HNS explosive. The increased yield of HNS can be achieved by reacting 2,4,6-trinitrobenzyl halogenide with potassium hydroxide in methanol. 2. Another method of forming HNS is the oxidation of TNT with sodium hypochlorite. 10 parts of 5% sodium hypochlorite solution are mixed with a chilled solution of 1 part of TNT in 10 parts methanol. The solution is then allowed to stand at ambient temperature until HNS precipitates as a fine crystalline product. The HNS precipitate is then recrystallized from nitrobenzene to give pale yellow colored needles. Ammonium nitrate. Ammonium nitrate is formed by injecting gaseous ammonia into 40 to 60% nitric acid at 150 degrees Celsius. Dense ammonium nitrate crystals are formed by spraying droplets of molten ammonium nitrate solution greater than 99.6% down a short tar. The spray produces spherical particles known as sprills. These crystals are non-absorbent and used in conjunction with nitroglycerine. TATB 135 triamino 2,4,6 trinitrobenzene. Another explosive formed by C-nitration process is TATB. It is produced by the nitration of 135 trichloro 2,4,6 trinitrobenzene, where 135 trichloro 2,4,6 trinitrobenzene is prepared by the nitration of trichlorobenzene with a mixture of nitric acid and sulfuric acid. 135-trichloro 2,4,6 trinitrobenzene is then converted to 135-trinitro 2,4,6 triaminobenzene (TATB) by nitrating with ammonia. The yellow-brown crystals of TATB are filtered and washed with water. TNT 2,4,6-trinitrotoluene. TNT is also produced by the C-nitration process. It is formed by the nitration of toluene with mixture nitric and sulfuric acids. Toluene is first nitrated to mononitrotoluene and then to dinitrotoluene, and finally it gets converted to crude trinitrotoluene. Dynamite. Dynamite is basically divided into gelatin and non-gelatin classification. Gelatin dynamite is prepared by dissolving nitrocellulose in nitroglycerine at 45 to 50 degrees Celsius to form a gel. The mixture is stirred by large vertical mixer blades. Once the gel is formed, the other ingredients are added. The explosive mixture is then extruded or pressed into long rods, which are cut into smaller pieces and packaged into paper cartridges coated with paraffin. The manufacture of non-gelatin dynamite is similar to gelatin dynamite, except that nitrocellulose is not used in the formulations. Gelatin dynamites are basically of 4 types: gelatin dynamite, semi-gelatin dynamite, gelignite, and ammonia gelignite. Gelatin dynamite, gelignite, and ammonia gelignite contains 25 to 55% nitroglycerine, 1% to 5% nitrocellulose, wood meal as a fuel, whereas semi-gelatin dynamite contains 15 to 20% nitroglycerine, 1 to 5% nitrocellulose, and wood meal acts as a fuel. They all differ in the use of oxidizer. Inorganic nitrates are the oxidizer in gelatin dynamite and semi-gelatin dynamite, whereas sodium potassium nitrate and ammonium nitrate acts as an oxidizer in gelignite and ammonia respectively. Non-gelatin dynamites are of following two types: non-gelatin dynamite and ammonia dynamite. Non-gelatin and ammonia dynamite both have 10 to 50% nitroglycerine and wood meal. In non-gelatin dynamite, sodium nitrate or potassium nitrate act as an oxidizer, whereas in ammonia dynamite, oxidizer is ammonium nitrate. Homemade explosives, Molotov cocktail. A Molotov cocktail consists of a glass bottle semi-filled with flammable liquid, usually gasoline, petrol, or alcohol, generally methanol or ethanol. The mouth of the bottle is fitted with a cork or other type of airtight stops, rubber, glass, or plastic, and a cloth rag fixed securely around the mouth. The weapon is used by first soaking the rag in a flammable liquid immediately prior to using it, lighting the rag and throwing the bottle at the target. The bottle shatters on the impact, spilling the flammable liquid over the target, which is then ignited by burning rag. Improvised explosive devices, briefcase bomb. An improvised explosive device (IED) is a product assembled in a contravention to the existing rules of law of nation, adopting unconventional or semi-conventional methods of formulating ammunition explosives with a criminal anti-national intention. IED is also known as homemade bomb. For example, roadside bombs, letter bomb, bombs incorporated in briefcase, vehicle, etc. Letter bomb. A letter bomb is defined as an explosive device sent via postal service and designed with an intention to injure or kill the recipient when opened. They have been used in terrorist attacks also. They are usually designed to explode immediately on opening with the intention of seriously injuring or killing the recipient, who may or may not be the person to whom the bomb was addressed. Components of an IED. IEDs are formed by incorporating destructive, lethal, and noxious pyrotechniques or incendiary chemicals. An IED is basically composed of explosives, a detonator, a power source, battery, and an initiation mechanism, switch. Search procedures for locating an IED. The following do's and don'ts should be followed while searching for an IED. 1. Don't touch or handle suspicious object. 2. Don't assume that merely one device is planted. 3. Use maximum 2 persons per room or for all area up to 250 square feet. 4. Clearly mark the area to be searched. 5. Trust nothing and assume nothing to be safe. 6. Obtain maximum information about the device. 7. Carefully listen to any unusual voice, sound before entering a room. 8. Be careful from any hidden danger at the entrance itself and also at other places and throughout the search. 9. Make a visual survey of the entire area of the room. 10. Search the area back to back. 11. Immediately report regarding the area and the suspected material. 12. Ask for help from expert. Booby trap. In simplest terms, we can define a booby trap as a device which is made with an intention to startle, surprise, attack, harm, or kill an individual. A booby trap is generally triggered accidentally by the presence or movements of the victim. Booby trap often has some form of entice to attract the victim towards it. Sometimes the booby trap is planted on busy roads or is triggered when the victim performs some action like opening a door, picking up something, switching something on or off, etc. Precautions with letter bomb. Following are some precautions that one needs to take when encountered with a letter bomb. 1. Evacuate all persons. 2. Stop admission into the room. 3. Do not open letter using hand. 4. Do not smoke near the bomb. 5. Do not cut any distended wire. 6. Do not jerk the letter. 7. Put letter through mail bomb detector. Nuclear explosives. A nuclear explosive is an unstable device that stems its energy from nuclear reactions. Virtually all nuclear explosive devices that have been devised and produced are nuclear weapons anticipated for warfare. Atom bomb is an example of nuclear explosive. Dirty bomb. It is generally known as radiological dispersion device (RDD). A dirty bomb is a radiological weapon which is a combination of radioactive material with conventional explosives such as dynamite. A dirty bomb is basically used to contaminate the affected area with radioactive material. The main purpose of a dirty bomb is to frighten people. It may also cause people to be exposed to radioactive material. Characteristics of explosives. The following are some of the important characteristics of an explosive which are very important to determine whether the explosive is suitable for a particular use. Availability and cost, sensitivity, sensitivity to initiation, velocity of detonation, stability, power, performance and strength, brisance, density, volatility, toxicity, explosive train, oxygen balance OB% or ohm, chemical composition, chemically pure compounds, mixture of oxidizer and fuel. Availability and cost. These include availability of raw materials, its cost, complexity, and its safety for manufacturing operations. Sensitivity is the ease with which an explosive can be detonated or ignited. An explosive is sensitive to shock, friction, or heat. Sensitivity should be considered in selecting an explosive suitable to its particular use. Sensitivity to initiation is defined by the power of the detonator, which is to certain to prime the explosive to sustained and continuous detonation. Velocity of detonation. It is that speed with which the reaction process spreads in the mass of the explosive, which is significant feature of explosive and differ according to the kind of explosive. Stability. One of the main characteristics of explosive is its ability to be stored without detonation, which is known as stability. Stability is affected by temperature of its storage, chemical constitution of explosive, exposure to sunlight and its electrical discharge. Power functioning under potency. The power of functioning of an explosive is its ability to do work, which is determined by some tests to measure the substance for its proposed use. Brisance. Brisance is defined as the shattering effect break, which is notable and separate from the total work capacity. Brisance regulates the efficacy of explosion in disintegrating bomb casings and grenades. The swiftness with which an explosive touches its peak power is a degree of its brisance. The brisance is tested by sand crush test. Density. Density is the mass of an explosive per unit volume. Volatility. Volatility of an explosive is the promptness with which it vaporizes. It influences the chemical composition of explosive, followed by reduction of stability, which increases the hazard of handling. Toxicity. Some of the explosives are toxic to that extent which require special handling due to hazards caused by them. Besides explosives, some of their derivatives, decomposition products, residues, and released gases can also be toxic. The harmful product may be any heavy metal such as lead, mercury, etc. nitric oxides relieved from TNT and others. Explosive train. Explosive material may be slotted in the explosive train of a device or system. For example, pyrotechnic leads to the ignition of booster, which causes the main charge to detonate. Now let's understand what an explosive train is. It can be defined as a triggering chain of events that ultimately lead up to the detonation of explosives. Oxygen balance. Oxygen balance is the degree to which an explosive can be oxidized. The sensitivity, strength, and brisance of an explosive depends on oxygen balance to some extent and approach to their maxima as oxygen balance approaches zero. If an explosive contains oxygen to convert all of its carbon to carbon dioxide, all of its hydrogen to water, and all of its metal to metal oxide with no excess molecules, the molecule is said to have a zero oxygen balance. The molecule is said to have a positive oxygen balance if it contains more oxygen than is needed, and a negative oxygen balance if it contains less oxygen than is needed. Chemical composition. An explosive can be characterized based on the chemical composition, which is either a chemically pure compound, such as nitroglycerin, or a mixture of a fuel and an oxidizer, such as black powder or grain dust and air. A. Chemically pure compounds. Some chemical compounds are unstable. Every molecule of the compound separates into two or more new molecules, mostly gases, with the liberation of energy. Example, nitroglycerin, acetone peroxide, organic peroxide, TNT, nitrocellulose, RDX, PETN, HMX. B. Mixture of oxidizer and fuel. An oxidizer is a pure substance molecule that in a chemical reaction can contribute some atoms of one or more oxidizing elements in which the fuel component of the explosive burns. On the simplest level, the oxidizer may itself be an oxidizing element such as gaseous or liquid oxygen. Example, black powder, potassium nitrate, charcoal and sulfur. Flash powder, Ammonium Armstrong's mixture, Sprengel explosive, ANFO, Shedits, oxyliquids, panclastids.
Dear students, let us now summarize what we have learnt in this module, which was focusing on explosives. We have studied that explosives are the substances, elements, compounds or mixtures which are capable of exerting pressure on its surroundings and leading to an explosion via transformation. Explosives can be used legitimately, such as for blasting rocks, for mining purpose, in spacecraft propulsions, etc. And they can be used for illegal purposes, such as in blast for causing destruction to individual or nation. And as forensic scientists, you will be dealing more with the illegitimate purpose they have been used for. The explosive we have seen can be classified as low, high or miscellaneous types. The low type of explosives experience deflagration at degrees that can vary from a few centimeter per second to about 400 meters per second. High explosives undergo detonation with explosive velocity ranging from 3 to 9 kilometers per second. Gunpowder is a mixture of sulfur, charcoal and potassium nitrate and was the very first chemical explosive. So, this we have studied in detail. We also studied that primary high explosives are extremely sensitive to mechanical shock, friction or heat. Secondary high base explosive are relatively insensitive to shock, friction and heat on the other hand. This also we had studied. Then we studied about RDX. RDX is also formed by various preparation techniques such as SH process, K process, W process, E process, K method, that is the Beckmann process. HMX is formed by a byproduct during the manufacture of RDX by the Beckmann process. So, this also is an explosive. We also studied the rate of detonation of dynamite is 4900 to 25,400 feet per second. We also studied a glass bottle half filled with inflammable liquid and whose mouth is closed with a cork or any airtight plug with a cloth rag fixed securely around the mouth is known as Molotov cocktail. An IED is basically composed of an explosive, a detonator, a power source which is battery and an initiation mechanism as switch. We also studied that the manufacture of non-gelatin dynamite is similar to gelatin dynamite except that nitrocellulose is not used in its formulation. So, dear students, I think all this information will be making you more knowledgeable so that you can handle the scenes where explosions have happened.